Alright, so presentation 4.2. So this is the second half of module 4, which will see out the Python Essentials 1 course. So this one will cover multiple parameters and recursions in functions, what tuples are, dictionaries, data processing, how to handle errors, and testing. First half of the chapter were how to deal with function results and scope. And if you remember, scope was talking about how the name has a power, whether it's inside the function or global. So functions can have multiple parameters, and what we have to ensure when we go through it is that when we call the function, we have it enable all the parameters. So we need, if the function calls for 4 parameters, then we've got to make sure when we call the function we give it those 4 parameters. So we need to make it easier on ourselves, and one of the things we can do in our code is put those comments in and explain what those parameters are and how we do it. So looks a bit scary, but what we can do is break them up. So we started on the left, everything laid down one after the other. Now we can shrink the presentation if you like. So what we can do is, rather than having the standard if loops one after the other, we can put them in one line and separate them with an OR. It's the same as what we had, but it's condensed. Now, is this more efficient? As far as the code's concerned, it is, because it can go through and execute one line instead of multiples. But does it improve the readability? I'd argue when you're starting out, probably not. But long term, as you get more efficient in coding and being able to read it, you'll find it easier to have the shortened version. So we can use the OR and we can use AND in these functions, so that, once again, instead of having multiple if statements, we can shrink them down and combine them with AND, so they've all got to be met. Now, Python's very good at doing equations. So how do we do a square root? Well, a square root is x to the power of a half. So how do we do exponents, the powers? So x to the power of 0.5 is the square root of x. So just a quick reminder of how the powers work. Factorials. So this is how we multiply all the numbers together. So have a play with that. It's rather interesting way of doing some calculations. And it's a bit of fun. Now, I know you're itching to go off and try it, but here's what we're talking about. So the factorial function, so if n is greater than 0, then we return none, and then we can increase it. So while I is in the range, we can get a product. So you can actually print this out and have them sum all the numbers together. Well, not sum, your multiplication. So factorials can greatly increase a number, and they're a bit of fun. Where you would work it in most things, nah. So fib numbers, so we're doing every subsequent number. So it's rather interesting. So what's it look like? Again, purely mathematical. I can't. The only bit of maths that I've used since leaving really is Pythagoras theorem. Except for when I was in uni doing cyber encryptions and that, and having to do all that lovely calculations around that. But there will be times where you need to do complex equations, and this is a demonstration that you can go through and with a bit of planning do it. Give it a try. It gives you some interesting results. So tuples. So sequence types gives us the ability to browse element by element. Multiplicity allows us to adapt things on the fly. So this means we can update a value in situ. In other words, we don't have to pull it out and redefine it. So we have information that we can modify and information that we can't. So we need to be able to know the difference between the two. And remember, a list is a multi-value variable. A tuple is the same except for one major difference. We can't modify the values or the elements within this storage system. So once it's defined, that's its values. So in a list, we use the square brackets. In tuples, we define it with the parenthesis. So once we have it defined, they're locked in type. The only way we can change values in a tuple is to totally redefine the tuple. And just like a list, we can use different data sets. So integers, floats, strings. Now, we can create a few special ones. So we can create an empty tuple, and we can use a one element tuple. So the rules and modifications, so everything you can do into a list, as far as, getting the list of indexes, pulling the information out, joining tuples and multiplying tuples. This all works same way as the list. Just remember that you're not going to modify the actual values within the tuples themselves. But you can certainly recall all the individual elements at any time, manipulate the values, and inject them into new variables. A dictionary is another type. Now, what are we looking for here? We're looking for a key with a value. Just like a normal dictionary works in like a bilingual. So you have your English words and say your Japanese words. So you look up one and it'll give you the other. So this is the key and the value type scenario. So you must have key pairs, and you can't repeat the key. So each key's unique. They're immutable. So in other words, they're not changeable. Again, you can get an index. So you can pull out the length. But remember, this is a dictionary, not a list. So it's basically a one-way tool. You can search for the keys, but not for the individual values stored in the key pair. So what's it look like? You have the dictionary name, and then the actual entries, the elements, are stored within the curly braces, and the key and the value are separated by a colon. Then each key pair is separated by a comma. Now, if you're running an older version of Python, I think we're currently up to 3.10. So the data is basically stored as it was written. So we can pull the values out, but we just need to know what the key is. And we do this, for example, using the print function. We tell it we're going to pull a dictionary, so the dictionary name, and then using the square brackets, we quote the key inside the square brackets. So this is equivalent to indexing in a list, except for these are names. So it's going to just look for the name in the key pair and then bring out the value. Keys are case sensitive. So Susie with a capital S and all under small caps, whatever, are different. So just remember, you gotta use the correct capitalization, and if you call a key that doesn't exist in that dictionary, you will result in an error. Excuse me. So we can store these in a fashion that is easier for us to read. It comes down to how you want to do it. So we can bring about a system where we go through and pull out all the keys, just like we did with the indexes, and get their values. So in this one, we've got basically the pets on the place, and we're going to go through for each key and print the value. A dictionary can get sorted, but again, newer versions of Python basically are going to store it in a pre-sorted order, whereas prior to 3.6 they weren't sorted. So the sort method is really only necessary if you've got older versions of Python running. So this works the same way as sorting a list or anything else that we've done before. It'll give you an ascending order, so it'll sort it in alphabetical order for you. So in here, we can do our little conversion of items. So this will go through and set up a tuple cat for each. Values method just extracts the stored value for each key pair. This works the same way as basically the keys. We can change the values, or what we've got to do is give it the correct key and the new value to be stored. So we do this with the dictionary name, in the square brackets the key value equals the new value to be stored. So again, a bit like a list. Appending allows us to add to the end. So this will be the default if the key doesn't already exist in the dictionary. It appends it to the end and increases the size of the dictionary. The other way you can do it is with dictionary update method, but that's a little bit longer So if we remove a key, it automatically removes the value associated with that key. Remember, it is a key pair storage system. So if we remove a key using the delete function, it also removes the value associated. Alright. Coding will always develop some form of error, whether that's our mistake due to our typing, or if we've made an error in judgment and not given correct number of parameters. Or there's lots of reasons why errors will occur, such as a bad input from the user. Now, these are generically termed bugs, and we need to know how we're going to handle them. So, with a large program, known bugs are listed, and sometimes it is a cost analysis on whether it's actually financially viable for us to go back and work on the actual fixes of those bugs. So, a reason for a bug being there is it could be too expensive to go back and fix the code. Or it could be a notation going, yes, we've realised this bug's here and we'll eliminate it on the next update. So we need to know what we're going to do with it. So Python's going to spit us back a traceback message with, the file, where it's located, the error is located, so what's caused the error, and then give us an idea of why it was invalid. So this is known as an exception, and it'll give us the value error. Now, we'll cover more detail on validation and errors in the second course under chapter 3, which is the object-oriented programming chapter. So we'll delve into that in a lot more detail there. So what we need to do is work out a way that we can try something to see if it works, and then maybe have an alternative. So what we can do is break it up. So we can use try keyword and place the code that we think may cause an error under the here, and the except will be called when that faults. So basically think of it as we're going to do something a little dodgy, going to put it under the try, so we're going to try this code. The except keyword is the exception. So we want to clean that up, apologize, give an alternative. Alright, so basically what's in the try is something we want to attempt, But if that doesn't work and it spits out an error, then we're going to go under the exception and do something that will fix or resolve that error. Now, under normal conditions, an error will terminate. But if we put it in the try section, your program doesn't get terminated. So we've got to get our jail free card, put it in the Monopoly terms. So the program doesn't terminate. It jumps to the first line under the exempt keys, and no other part of the branch in the try will be executed. So if an error occurs, it stops trying to execute the code in the try branch and directly goes into the exception branch and executes the code there. So the exception code is only executed if an error occurs in the code in the try branch. So you won't get it happening unless it's an error. Once you either successfully finish the code in the try branch, it goes back to the normal programming, or it executes what's in the exception code, finishes that branch, and then goes back to normal. Can we have multiple exceptions? Yes, we can. Why do we want multiple? Well, when an error occurs, we get that value error raised. So it tells us what type of error it was. So we can create code for specific error handling. So it looks at the value error raised and loops through each exemption to meet that condition and then executes the branch. Okay, only one branch will be executed before returning to the main program. So you can have a different message or a different way of handling each error type, as well as setting up a default. Okay, so we got two specific error codes in mind in this example, and then one that doesn't have a condition clause. So this becomes our default statement. If the others aren't explicitly matched, then our default is executed and then go back to normal programming. So some of the most common error codes is zero division error, value error, type error, attribute error, and syntax. So it's bad if we try to divide by 0. Okay, spits us out an error straight away. Values are if it's the wrong type, data type. So if we're trying to get an integer and somebody gives us a float, or then we can have an error. Again, going through each, there's a good library of errors that you can look up, but they're the common ones. So, how testing is handled? Well, we can go through and have the else if parameters. Okay, so we can have multiple branches of ifs, and when we're running the test, Python will only look at the bits it's executing. So in here, if the temperature is above 0, then execute that. Alright? It doesn't necessarily look at this bit where it's below 0 if the value is not below 0. So therefore it never checks that bit of syntax to see if it's valid. So we're missing a T there. So that will be overlooked because it never went through and executed that piece of code. So what you need to do as part of your testing regime is know all your permutations and branches. So when you inject data sets into your program to test, you test all the ranges so that all your branches are activated in the testing regime. It is a tester's job to find the bugs. Alright? Now, this is a condemnation of you as a coder. It just means somebody missed a step in the logic, and for every bug a tester finds, it's one that the client doesn't. So by debugging the program before it gets released, we can make our software more user-friendly, which means the reputation for our product gets better and we get repeat customers. Now, debugging software is available for most languages and it comes in a variety of forms. The most common one that we'll be using is built into our lovely Visual Studio, for example. It comes up, tells us what the error codes are, and highlights where it is. So it tells us what's going on, what's caused the error, and points us to where it is. Okay, so Module 4 has some lovely labs. These labs will take between half an hour and 2 hours, depending on how dedicated to the process you are. Yes, very fun. You know, how quick are you typing? Are you stopping for coffee? You know, there's too many variables in there. So, in summary, we went through the fact that functions can have more than one variable. Well, it's not variable, parameter. So, recursions, tuples, the dictionaries, and data processing. That's interesting. I fixed that before starting the PowerPoint, yet it didn't save it. Interesting. All right. Done on the fly. So we're not teasing, we're testing. As I said, more on error codes, validation and testing procedures when we go through chapter 3 of part 2. Or the Python Essentials 2. Now, good news is you've hit the end of Python Essentials 1. So, if you wanted to, you could go off and do a certification which will give you an entry level certificate. But more importantly, you've got a part 1 assessment that you must do before unlocking Python Essentials 2.
Is that the summary test?
Yes.
Ah, okay.
Alright, you must complete the summary test before it unlocks the second course. It's a prerequisite. Okay, so this allows you to continue in the sandbox environment and practice as we go through. So it's kind of important. So I would suggest it may be important for you to review the last 4 chapters before doing that summary test. Okay, now, next session we'll be starting chapter 1 on Python Essentials. So, sometime during this week, please do that lovely summary test. For the people on the recording watching this later, thanks for joining.